Welcome to The Explainer. Today, we're going to crack the code on one of music theory's most powerful, and let's be honest, often most intimidating tools, the circle of fifths.
You've seen them, right? Those little sharp and flat symbols all clustered together at the beginning of a musical staff. And if you've ever looked at that and just felt a little intimidated, well, you are definitely not alone. That cluster of symbols, that's called a key signature.
Yeah, look at this. This is the key of B major, and it's got 5 sharps. It looks super complex, right? But what if I told you it's all part of an elegant, totally logical system? To really get it, though, we got to go back to the beginning, back to music's most basic formula.
So, to crack that code, first, we've got to understand the basic building block of pretty much all Western music, and that is the major scale.
Okay, so think of this like a recipe. It's a specific sequence of steps. Whole step, half step, then whole, half step. Got it? 2 wholes, a half, 3 wholes, a half. It doesn't matter what note you start on. If you follow that pattern, you will always get that bright, happy sound of a major scale. And the simplest example of this, the C major scale. If you just play the white keys on a piano starting from C, you'll see it perfectly follows that recipe. No black keys needed. It's our baseline, our ground 0, 0 sharps, 0 flats.
But here's where it gets interesting. What happens when we try to build that same scale, but we start on a different note? Let's say G. Well, if we just stick to the white keys again, starting from G, our recipe breaks. It works almost all the way through, but then, right at the end, that jump from E to F is only a half step, and our formula needs a whole step there. See the problem? That one wrong interval is what we need to fix.
And the solution? It's actually super simple. To get that whole step we need, we just raise that 7th note, the F, by a half step. We make it an F sharp, and just like that, boom, the formula is fixed. We have a perfect G major scale.
Now, you could write a little sharp symbol next to every single F in the whole piece of music. But man, that would get old fast. So musicians came up with a shorthand. They just stick the sharp right at the beginning, and that is the birth of the key signature. It's a little instruction that says, hey, for this whole song, any F you see is actually an F sharp.
So, if we do this for every single possible starting note, we end up creating a whole bunch of different key signatures. Some with a bunch of sharps, some with a bunch of flats. And you can imagine this could get really confusing really fast. How are you supposed to remember all of them? Well, luckily, there's a map for all this, a single diagram that brings this beautiful, perfect order to what seems like total chaos. And it's called the circle of fifths. This thing is the master blueprint. It lays out all 12 musical keys, and it shows you exactly how they're all related. It's more than just a chart. Think of it as a GPS for music. Okay, so how do you actually read this thing? Trust me, it's way easier than it looks. The secret is just knowing which way you're going on the circle, clockwise or counterclockwise.
All right, check it out. At the very top, you've got C major. That's our home base. No sharps, no flats. Now, if you move one step clockwise, you jump up a perfect fifth. That's the distance from C to G, and you add 1 sharp. Go the other way, counterclockwise, and you jump down a fifth from C to F, and you add 1 flat. See the pattern? It's that simple. And get this, there's even a pattern to the sharps and flats themselves. They always show up in the exact same order. And musicians have these great little tricks to remember them. For sharps, just remember this sentence. Father Charles goes down and ends battle. And for the flats, it's literally the same thing, just backwards. Battle ends and down goes Charles's father. Pretty clever, huh? The circle also gives us a couple of amazing hacks to figure out any key signature, like instantly. For keys with sharps, just find the last sharp listed and go up 1 half step. That's your key. So if the last sharp is a G sharp, you're an A major. For flats, it's even easier. The key is simply the second to last flat. That's it. Okay, that's cool. We can read the map, we can identify keys, but so what? Why does this really matter? Well, this is where it gets really powerful, because the circle isn't just some diagram you memorize. It's an actual toolkit for writing, understanding, and even feeling music. For starters, the circle instantly shows you something called the relative minor for every major key. They're like musical twins. They share the exact same key signature, the same set of notes, but they have a different starting point. And that gives them a totally different mood. C major is bright and happy, right? Its relative minor, A minor, uses all the same notes but feels more, somber, maybe a little more thoughtful. And here's a little pro tip you hear musicians talk about all the time.
To find that relative minor without even needing the circle, just start on your major key's note and count down 3 half steps. So from C, you go down 1, 2, 3, and you land right on A. C major, A minor. Works every time.
But here is maybe the circle's biggest superpower. It's a map for chord progressions. See, chords that are next to each other on the circle just sound good together. And if you move counterclockwise, say from D to G to C, you create this incredibly powerful feeling of tension and then release. That one simple movement is the famous I to shop V to 1 progression. It is the absolute foundation of so much jazz, pop, and classical music. It's everywhere.
So this whole time, we've been looking at the circle of fifths as this model of perfect mathematical beauty, a closed loop. But it's hiding a secret, a really fascinating one, a tiny little imperfection that, it turns out, our entire system of music is built on.
Okay, so in the world of pure physics, a perfect fifth has a very specific pure mathematical frequency ratio. But here's the crazy part. If you take a note, say a C, and you stack 12 of those perfect fifths on top of each other, you don't land back on a C. You actually overshoot it by just a tiny bit. The circle doesn't actually close.
That little leftover bit, that tiny overshoot, has a name, the Pythagorean comma. And what it really means is that a truly pure circle of fifths isn't a circle. It's a spiral that goes on forever. So what do? We cheated. To make our instruments like pianos and guitars actually work in every key, we created a system called equal temperament. We basically shaved a tiny, imperceptible sliver off of each fifth to make them all fit. It's a compromise that forces that infinite spiral to close up into the perfect circle we all use today.
So that leaves us with this final, kind of mind-bending thought. What if the beautiful, logical system that we use to create all music, from the simplest little tune to the most complex symphony, what if it's all built on a fascinating, elegant mathematical compromise? It's not really a flaw, is it? It's more like a beautiful, necessary fiction. A perfect lie.